have to be able to account for all of the valence electrons around the atom when you draw the Lewis structure out. So if you do boron, boron has 3 valence electrons, 1, 2, 3, 3 dot. Okay, and if you have bromine, bromine group 7A, okay, you have a total of 30. You have a total of 18, 28, and 35 electrons in there. Okay, when you put Br down, that represents the 28 electrons and the protons and neutrons in here. So you have 7 valence electrons, one on each side. You get 3 pairs plus 1 plus a single atom. So this would be the Lewis structure for bromine. This would be the Lewis structure for boron. Now that we know how to draw a Lewis structure for elements, we want to take a look at each of the elements there. Beryllium group 2A, 2 valence electrons. Lithium group 1A, 1 valence electron. Okay, so one thing that we mentioned at the beginning there, the group number for main group elements, the group number equals to the number of valence electrons. You have to, in order to determine how the electrons are being shared, you have to know how many electrons we have to begin with. Okay, so you have to be able to count the total number of valence electrons there. Okay, so we're talking about the valence electrons, not the total number of electrons. The last topic that we had yesterday in class was isoelectronic. Isoelectronic refers to, is the term that we use to describe species with the same number of total electrons. Now we're looking at just the valence electron. Okay, so this is the list of elements in group 1A through 8A in the second period and the third period. These are the Lewis structures for these different elements there. Group 1A, 1 dot. Group 2A, 2 dot. Group 8A, 8 dot around those elements there. Okay, so N2, NS2, NP6. 6 plus 2, 8 electrons there. If you look at the electron configuration for these main group elements there, you can see group 1A, 1 electron, group 2A, 2 valence electron, group 3A, 3 valence electron, group 8A, 8 valence electron. So that's something that we need you to remember. When you deal with main group elements, non-metal elements are pretty much all main group elements. When you deal with main group elements there, you will be able to tell, based on where they are in the periodic table, you will be able to tell how many valence electrons you have. Okay, this is the guideline on how to draw a Lewis structure. And if I read through this, and half of you will probably fall asleep if you haven't already fallen asleep. And we will give you some examples on how to draw a Lewis structure. But these are the guidelines that we need you to, what's that word, memorize. You have to remember the basic guidelines for drawing the Lewis structure. Okay, so the first thing here is that when we ask you to draw the Lewis structure, we have to be able to determine what is what we call the central atom or the terminal atom. Okay, so we ask you to write the correct skeletal structure for the molecule. Now, hydrogen atom is always going to be terminal at the end. You cannot put hydrogen in between 2 atoms there. Because if you put hydrogen in between 2 atoms, you're forcing the hydrogen to take in 4 electrons. The hydrogen will tell, I don't have enough room for 4 electrons. I can only take 2 electrons. Okay. Using water as an example when you draw a Lewis structure. Okay. We'll give you some exercise problems here afterwards, and we ask you to draw a Lewis structure of these different molecules there. So the first thing says we need to write this correct skeletal structure for the molecule. So we have H2O as our formula. Now there are different ways, and possibly there are more than one ways to connect the atoms together. We can have HOH. We can do HHO. Well, according to the first guideline there, it says, well, hydrogen is always terminal. You cannot put hydrogen in the position, simply because here you get 2 pairs of electrons. Hydrogen doesn't have enough room to accommodate 4 electrons. Only 2 electrons. So this would be the only correct way to draw the Lewis structure, to draw the skeletal structure of water, HOH. You can't have HHO. Okay? So that's the first thing there. Now, how do you determine if it's other than hydrogen atoms involved? How do you determine which one is the central atom, which one is the terminal atom? Well, generally speaking, the atom with the lowest group number would be your central atom. The atom with the higher group number, talking about group numbers in the periodic table. The atoms with higher group numbers would be your terminal atom. So, for example, if you have H, well, let's not use hydrogen then, but carbon dioxide. Now, in this case, carbon is group 4A. Oxygen is group 6A. So, carbon is going to be your central atom. Oxygen, oxygen. So that's the correct skeletal structure. Okay, that's the first step there. You need to determine which one is central atom, which one is the terminal atom. Okay. After that, you want to calculate the total number of electrons, total number of valence electrons. Now carbon is, well, let's do water first. Okay. Oxygen is group 6A. So you have 6 electrons. Hydrogen is group 1A. You get 1 electron, but you have 2 in there. Okay. So 1 electron each from hydrogen, you get 2 hydrogens in there. Total number of valence electrons, you get 8 electrons. So once you figure out the total number of valence electrons, you're going to try to distribute those electrons. And the thing here is that sometimes you're dealing with ions, polyatomic ions. If you have a negative charge, you add 1 electron to the total number. If you have a positive charge, you subtract an electron from the total number. Okay. So you have to pay attention to the polyatomic ions where you have positive charges and negative charges. Now that we have 8 electrons, we try to draw a dashed line connecting 2 atoms together. Each dashed line represents 2 electrons. So out of the 8 electrons, we used 2 here, 2 here. We used 4 electrons. We have 4 electrons remaining. How do you distribute those 4 electrons? The general guideline says you distribute the electrons to the terminal atom first. When each of the terminal atom has 8 electrons, then if you still have extra, the electron will go to the central atom, with the exception of hydrogen. Hydrogen only needs 2. Hydrogen has 2. Hydrogen has 2. So you have 4 more electrons left over. Well, oxygen only has 4. Oxygen needs 8. We put those electrons on oxygen. These are what we call the lone pair electrons. They are not used for bonding with hydrogen atoms. They reside right on the oxygen atom. So this would be the Lewis structure for water. Another example, carbon dioxide. Okay? We draw the skeleton structure there, oxygen, carbon, oxygen. Carbon is group 4A, so 4 electrons, plus group 6A, 6 electrons times 2. Well, you get a total of 16 electrons. Okay. Once we determine who is the central atom, who is the terminal atom, once we determine the total number of valence electrons available among those 3 atoms there, the next step, we're going to draw a line connecting carbon to oxygen, carbon to oxygen. So we've used, out of these 16 electrons, we've used 2 here, 2 here. We have 12 electrons remaining. According to the guideline there, we're going to distribute these 12 electrons to terminal atoms first. Each one needs to have 8 electrons. So 2, 4, 6, 2, 4, 6. Total of 12 electrons completely used. Now you look at the structure here.